My project is evaluating the effect of commonly used synthetic food dyes such as red 40, yellow 5, and blue 1 on the regeneration and growth rate of planarian flatworms. The question is, will planarians show a change in the regeneration and growth after being exposed to each dye and different concentration levels? The reason that food dyes are used in my project is because over 40% of food dyes targeted for adolescents in the United States contain synthetic dyes. Yellow 5 and red 40 account for 90% of the artificial dyes used in the United States. Planarians being bioindicators mean they are indications of an ecosystem's health. This helps us understand environmental impacts of artificial dyes. They can display cell and tissue repair. In my research, planarians will demonstrate their regeneration process after consuming synthetic dyes. Previous studies have investigated 6 artificial dyes on other worms and have tested other chemicals on planaria, but not these specific food dyes. This leads to my project of testing red 40, yellow 5, and blue 1 on planaria regeneration. My hypothesis is that the 1% concentration group will show slowest and possible mortality. Regeneration will decrease as dye concentration increases, and there may be differences in regeneration based off the different dye types. My independent variables are dye type and dye concentration. My dependent variables are regeneration time, change in body length, survival rate, and regeneration success. My controls are temperature, pH levels, cutting method, feeding schedule, and frequency of water changes. My main materials involve 0.1% and 1% of each red 40, yellow 5, and blue 1. I will also need 14 planaria. Other materials include petri dishes, light microscope and camera, pH strips, pipettes, spring water, blade, tinfoil, and ethanol. Safety procedures involved gloves, goggles, washing my hands, washing each container before and after using, and using ethanol to clean surfaces and tools. The blades were carefully used when cutting the planaria and were handled in designated sharps container after use to prevent injury. The synthetic dyes and ethanol were placed in waste containers. Each organism was ethically disposed in boiling water. The main goals are to provide an understanding of chemical effects such as low versus high dye concentration levels on planarian health and regenerative abilities, observe for a difference in dye types, and study long-term growth of the organism. In the early preparation days, I held the planaria in room temperature spring water while feeding them raw boiled egg yolk. They were stored in covered dishes and water was changed out every few days to keep stable conditions. After preparation, each planaria was randomly assigned to a group. Each dye has 0.1% and 1% concentrations in spring water. Each dish was filled with approximately 8 to 10 milliliter concentrations. In order to cut the planaria, they were immobilized and placed in shallow waters and cut into head and tail fragments. The blades were sterilized using ethanol. Measurements were also recorded. These are images of my solutions in planaria during setup. This was me cutting the planaria and the microscope images of a fragment. Concentrations of 1% dye was measured using 18 drops and 0.1% used 2 drops, each in 100 milliliters of water. Dishes were covered using tinfoil to reduce evaporation. Data was analyzed by the movement, formation, and body length. This chart shows each group and concentration, mortality rate, average length, and regeneration success, with the 0.1% showing more success in all categories. This graph highlights the differences in each dye and lengths. These are microscope images from blue 1 0.1%, blue 1 1%, yellow 5, red 40 1%, and red 40 0.1%. My results showed that yellow 5 and blue 1 1% dyes showed similar results of a high mortality rate, indicating that higher concentrations of the dyes may interfere with cellular repair processes. Red 41% also demonstrated this, however not as significantly. The 0.1% dyes showed higher average lengths after regeneration processes, demonstrating that the planaria were not as impacted by the lighter exposure to synthetic dyes than the 1% concentrations were. Higher concentration levels result in decreased regeneration and more mortality rates as opposed to lower concentration levels. These results confirm that exposure to artificial dyes can impact the tissue regeneration in planaria. It highlights the overall role in exposure to chemicals on the cell activities that provide regenerative abilities. Limitations include small sample sizes, time restrictions, and differences in size of original fragments. Future research may explore other dyes and get a closer look into specific cell activities that provide regenerative abilities. Real-world applications highlight human health concerns, especially for adolescents, environmental concerns and disruptions in ecosystems, and chemical exposure affecting cellular processes. And this is my bibliography.